The last method I want to present for solving quadratic equations is using the quadratic formula. I find that this is about the most well-known method. However, this is the method that I use the least when I solve quadratic equations because it's very easy to make an algebra error as you use and simplify the quadratic equation. So I tend to use the quadratic formula when the trinomial ax squared plus bx plus c is not factorable, so we can't solve it by factoring, and when the leading coefficient is not equal to 1. If the leading coefficient is equal to 1, I typically will solve by completing the square. So here's an example of a prime candidate of a quadratic equation that we would solve with the quadratic formula. 2x squared minus 2x minus 1 equals 0. I need to identify a, b, and c. So here a equals 2, b equals negative 2, c equals negative 1. And then it's simply a matter of plugging in these values to the quadratic formula, which, by the way, derive from completing the square. Completing the square is a more fundamental, earlier strategy for solving quadratic equations that then produced the quadratic formula. So I have negative b, that's the opposite of b. I'm going to say positive 2 plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c all over 2 times a. So there's a lot of simplifying that needs to happen here, and let's start inside the square root. The square root is going to reduce and look like this. Negative 2 squared is positive 4. And then if we think about order of operations, after evaluating the exponent here, the next thing to do is evaluate the multiplication. Negative 4 times 2 times negative 1. So that's going to be positive 8. I'm writing positive 8 because I have a negative here and a negative here. Multiplied together, the result is positive. That's going to be divided by 4. So I've already simplified it quite a bit. This is equal to 2 plus or minus the square root of 12 over 4. And you might be tempted to stop here, but we actually need to fully simplify these radical expressions. So the square root of 12 can be rewritten. We've talked about this already. I can rewrite the square root of 12 as the square root of 4 times the square root of 3. When I simplify that result, I get 2 plus or minus 2 root 3 over 4. Now, there's a common factor that divides out of all of these terms in the numerator and denominator. It has to divide out from both of these if we're going to simplify it, and that's the common factor of 2. So I divide everything by 2, and I get 1 plus or minus root 3 over 2. That's our final solution to this equation. X equals 1 plus or minus root 3 over 2. Remember, that represents two different answers. One is 1 plus radical 3 over 2, and the other is 1 minus radical 3 over 2. Both are solutions to this quadratic equation. Let's look at one more example. Let's solve 3x squared minus 6x equals 1 by plugging our values for a, b, and c into the quadratic formula. If I'm going to do that, I need to make sure that my format or template matches this one. So I'm going to rewrite this as 3x squared minus 6x minus 1 equals 0. Then we can say a equals 3, b equals negative 6, c equals negative 1. So what's our result? What's our solution for x? Well, it's the opposite of b, so I'm going to say positive 6 plus or minus the square root of b squared minus 4 times a times c all over 2a. So once again, let's fully simplify this result, starting within the radical and working our way out. So 6 plus or minus 36, and then I do the multiplication. Negative 4 times 3 times negative 1 is positive 12, and that's over 6. So we have 6 plus or minus the square root of 48 over 6. But we're not finished, right? Because the square root of 48 can be simplified, that can be rewritten. I'm going to rewrite that. I'll show that here on the side. The square root of 48 is the same as the square root of 16 times the square root of 3, which equals 4 root 3. So there's my simplification for the square root of 48. Let's put that into our solution. So I have 6 plus or minus 4 root 3 over 6. And then we're going to divide a common factor to finally simplify this. 6, 4, and 6 are all divisible by 2. So divide it by 2 and I get 3 plus or minus 2 root 3 over 3. Now there's more than one way to write this answer, so I might just take a minute to show it in another way. Here's the solution, but I could also break apart this factor and write it like this, which would give me 1 plus or minus 2 root 3 over 3. So this has the same meaning as what we wrote above. It's just a different way of expressing the final solutions. Again, this represents two solutions, whether it's here or here, because of the plus and minus signs.